Greetings, my young math Padawans. This is Lesson 4.5, Solving Polynomial Equations, Part 1. In this section, we're going to change gears a little bit. So in Section 4.4, we were talking about factoring polynomials. Now we're going to kick it up a notch and actually solve polynomial equations. I want to remind you that the easiest way to solve any polynomial equation is to set the equation equal to 0 and factor. I mean, that's why we spent so much time on factoring, because factoring is, in fact, the easiest way to solve any polynomial equation. So we're going to do that here with this first problem. 2x to the third equals 12x squared minus 18x. The first thing we're going to do is we're going to set it equal to 0. So that means I'm going to subtract my 12x squared from both sides. And I'm going to add my 18x to both sides to set that thing equal to 0. And then it's time to factor. So I'm going to pull out that list of all those factoring steps that I had in the last problem. And of course, the first one is to always look for a GCF. Is there something I can divide into all three of these terms? And yes, there is. I can divide into 2x. So I'm going to factor out the 2x. I'm left with x squared minus 6x plus 9, and of course equals 0. And then I'll keep factoring. I'll make sure that I can't factor down anymore. So the 2x is factored as much as it can be. But what about the x squared minus 6x plus 9? Can I factor that down more? And yeah, I can. There are a pair of numbers that multiply together to give me positive 9 and add together to give me negative 6. And that's negative 3 and negative 3. Okay, so now what? Once I have it fully factored, and I do in this particular problem, I'm going to do just like I did when I solved a quadratic equation by factoring. I set each individual factor equal to 0 and solve them separately. In this case, though, instead of having just two sets of parentheses, I'm going to have 3. So I have 2x that I'm going to set equal to 0. Then I'll set the x minus 3 equal to 0. And I'll set the other x minus 3 equal to 0. And I'll solve each one of these little linear equations separately. So that'll give me 0. That'll give me x equals 3. And the other one gives me x equals 3. Okay, so the solutions is x is equal to 0 and x is equal to 3. I don't need to write the other 3 a second time, because when you repeat yourself, people look at you funny. When you repeat yourself, people look at you funny. I know what you're thinking. Is he going to say it another time? Yeah. When you repeat yourself, people look at you funny. So anyways, just don't repeat your solution. There's no need to. Example 2. 5x to the third plus 8x equals 40x squared. We're going to solve this. If you think you got it, if you think you know how to factor, go ahead, pause the video, take a look, try it out, see if you can do it yourself. But I'm going to work it out for us right now. And of course, the first step we're going to do is we're going to set this thing equal to 0. So I will subtract my 40x squared from both sides. The next thing I'm going to do is I'm going to look for a GCF. Is there something I can divide into all three of these terms? Yeah, I can divide in a 5x. What am I left with? Let's see here. Dividing out the 5x gives me x squared minus 8x plus 16. I'll make sure this is not factored. I'll see if I can factor this anymore. Right, so I got the 5x. And what about this? What about this x squared minus 8x plus 16? Can I factor that more? You bet it. X minus 4 times x minus 4 is what that factors down to give you. Now, just like in the last problem, I'll take each factor, set them equal to 0, and I will solve them individually. So let's see here. This gives me x equals 0. Adding 4 to both sides, that gives me x equals 4. And again, so my solutions, x is equal to 0, and x is equal to 4. Don't need to repeat them. No, I'm not going to do it again. So why don't you take an opportunity right now to pause the video and try these two problems out. We will, of course, work out the solutions momentarily. But in the meantime, pause the video, try these two problems. All right, on number 1, I'm going to factor out what they have in common. Oh, looks like it's just a 2, or negative 2. That'll leave me x to the fourth minus 8x squared plus 16. And now it's looking for that pair of numbers. This is a quadratic-like equation that I got inside the parentheses. So I'm looking for that pair of numbers that multiplies together to give me 16 and adds together to give me negative 8. What could it be? Yeah. Did you say 4? You're right. It's x squared minus 4 times x squared minus 4. Now I'll just make sure that this is factored completely. So can I factor down x squared minus 4? Yes, I can. It's x minus 2 and times x plus 2. What about this x squared minus 4? Yep, it's the same thing as what I just factored. So when I now set each one of these factors equal to 0, let's see here, I got 1, I got 2, I got 3, I got 4. Then I'm going to set equal to 0 and solve individually. Now you might be saying, Mr. Haupt, you forgot all about this negative 2. You didn't set negative 2 equal to 0. Well, I mean, I could, but negative 2 does not equal 0, so I'm not going to get any solutions from that. So it was kind of pointless for me to even add that. So my solutions to this problem are x equals negative 2 and x equals positive 2. The other two solutions repeat themselves. I don't need to write them again. What about number 2? Can I factor out anything of that? You bet. There's a GCF. If I factor out the GCF, I get x to the 4th minus 4x squared plus 9 equals 0. And now I'll figure out what multiplies together to give me 9 and adds together to give me negative 10, because that is a quadratic-like equation. Well, that's negative 9 and positive 1. And now I'll just make sure that this thing is factored as much as it can be. So let's see here. Can I factor down the x squared minus 9? You bet. Can I factor down the x minus 1? You bet. I'll set each one of these factors equal to 0. Let's see here. What am I going to get? Well, from that parenthesis, I'd get x equals 3. From that parenthesis, I'd get x equals negative 3. Then I'd get x equals positive 1 and x equals negative 1. Folks, those are my solutions. I don't really have to actually physically set each factor equal to 0. I can sometimes do that in my head. All right, let's move on. We're going to go back and look at that problem number 1. That is the same polynomial that you'll see up here. And one of the things that I'd like you to notice, if you remember from that previous example, we found out that the solutions to that equation were x equals 2 and x equals negative 2. But do you remember how each one of them occurred twice, right? If you go back and look at that work. And what you'll notice right down here is negative 2 is there 2 times. And you also notice that x equals 2 is there twice as well. So what we say is we have negative 2. We say since it occurred multiple times, we say that it has a multiplicity of 2. And the same thing actually occurs here for positive 2. We say that x equals 2 has a multiplicity of 2. Right? So that's kind of really important here. So the solutions of x equals 2 and x equals negative 2 both have that multiplicity that we just talked about, multiplicity of 2. What I want you to notice is over here on the graph. This is the graph of this function. If you plugged it into Desmos, you would get the same thing. It would look a little something like that. Although I will warn you, you would have to adjust your y values accordingly so that you could see the graph looking like this. But what I want you to notice is I want you to notice what happens here at negative 2 and positive 2. There's 2 things I want you to notice. 1, this is where the graph crosses the x-axis, or touches the x-axis in this problem. And that's what's going to happen with any of these solutions to a polynomial equation. When you factor it, when you set it equal to 0, what you're really finding is you're finding the x-intercepts. We sometimes call these zeros. So zeros, solutions, they're almost the same thing. So we could say, instead of the solutions to this function f of x, we could say the zeros are at x equals 2 and x equals negative 2. Because of the multiplicity, what you'll notice that my polynomial just kind of touches the graph at negative 2 and changes the direction. Do you see how it's increasing? And then all of a sudden, it's decreasing and going down at negative 2. And the same thing occurs here too. It's increasing and then all of a sudden it touches the axis and it goes in the other direction. That's really important and a nice characteristic that happens when you have an even multiplicity, something you'll notice with your graphs as you work through them. Other important parts of this graph would be like the y-intercept, right? The y-intercept. And if you remember, how do you get the y-intercept? You'd set x equal to 0 and you'd solve it. So in this problem, when we set x equal to 0 and we plug it into our equation, now you can do it in a calculator as well, what you end up with is you end up with negative 32. So you should notice that the y-intercept is at 0, negative 32, which is that point right there, 0, comma, negative 32. And again, we have the two zeros at negative 2, 0 and positive 2, 0 that we got from the previous step. What else is important? Well, the other thing that I want you to remember, as we've talked about in the first section, is we have the end behavior. And our end behavior, according to this, the degree is even, and my leading coefficient, let me abbreviate, is negative. So because of that, I know the two ends of my function are going to point down. Did you notice how they both point down on the two ends? So I would be able to say that f of x goes towards negative infinity as x goes towards negative infinity, so pointing down on the left, and f of x is going towards negative infinity as x goes towards positive infinity, pointing down on the right-hand side. So don't forget about all of these things that we've talked about before. They can help you get a really good idea of what the graph may look like before you even graph it. Let me show you what I'm talking about. Let's consider x to the third plus x squared minus 6x. One of the first things that I'm going to do is I'm going to find the zeros. Find the zeros. So what I mean is set the equation equal to 0 and solve. How am I going to solve? Well, I'm going to factor. I'm going to solve by factoring. And I'll pull out that GCF first. And then I'll figure out what are the pair of numbers that multiplies together to give me negative 6, adds together to give me positive 1. That will be positive 3 and negative 2. So then when I set each one of the factors equal to 0, I'd get x equals 0, I'd get x equals negative 3, and I'd get x equals positive 2. These are the zeros of the function. They're the zeros of my function. That also equates then to being the x-intercepts. So I'd have an x-intercept here at 0. I'd have one over here at 3. I'd have one right here at 2. Those are my x-intercepts. Okay, what else? What else will I know? Well, I could find the y-intercept. Okay, the y-intercept would be helpful with sketching the graph. So I'll plug 0 into my equation, and that's it, 0 to the third plus 0 squared minus 6 times 0, and I get 0. And folks, that shouldn't surprise us, because if I'm going to be at the point x equals 0, then that's also the origin, so y better be equal to 0 as well. From here, what do? Well, from here, I also know something about the end behavior, right? The end behavior tells me that this is odd. The degree is odd. Degree is odd. And the leading coefficient is positive. So what does that tell me? That tells me that my left end is going to point down, my right end is going to point up. So I could say that f of x is approaching negative infinity as x is approaching negative infinity, and f of x is approaching positive infinity as x is approaching positive infinity. So points down on the left, points up on the right. Essentially, what I mean is I can add these two arrows to my graph to get a good idea of what's going to happen on the ends. Okay, what now? Well, now I can, to get a better idea of what this graph is going to look like, I can start creating a table of values for myself. What do I use? Well, you can use any numbers you want. But I want you to keep in mind that the zeros are at negative 3, 0, and 2. So if I know that I can include values like negative 3, 0 in my table. I can include the point 0, 0 in my table, and I can include the point 2, 0 in my table. From there, I'm going to just fill in with the numbers that maybe are in between. So maybe I'll try negative 4. Maybe I'll try negative 1. Maybe, why not, negative 2's in there too, I might as well. I'll figure out what positive 1, and I'll figure out what positive 3 is. And I can plug these values into my equation to figure out where those coordinate values would be. Now, I did this work ahead of time, so I'm not going to take the time to plug numbers into a calculator. You can do them, but just check to make sure you get the same ones. And from here, I can start plotting some points. So negative 4, negative 24, that's off my graph. That's not going to fit. Negative 1, 8, okay. I know that's not going to be that, but that's going to be like maybe up here. I know negative 2, 6, that's going to be there. I got the point 1, negative 4, that's all the way down here. 3, 18 is going to be off my graph. But from here, what I can do is I can start attempting to actually create my graph. So I will go ahead and connect the dots. I know what's going to have to happen. I know I got to go down through there to get down to that point to come back up. And I can get a really good idea of what my graph may look like. If you can't from there, the answer, of course, is to just do more coordinate pairs. Maybe pick some fractions. That's a ton of stuff to do with these problems. I know that, and I can't make it any easier. I can't make it any shorter. We got to go through all the steps to figure out what the graph looks like. At this point, I'm going to work through another example. If you think you got it down, why don't you pause the video and try it on your own? If not, feel free to stay with me right now and we'll work through this problem together. First things first, we're going to find the zeros of this, or the x-intercepts of this particular equation, and that means we set the equation equal to 0, and we're going to solve it. So let's see here. What is the GCF? I always look for the GCF first. So I'll pull out the GCF. Then I got to look at this parenthesis and say, can I factor that down more? And yes, I can. That's a quadratic-like equation, which factors down to be x squared minus 1 times x squared minus 1. Then I look at those individual parentheses and say, can I factor down x squared minus 1 more? Yes, I can. It's x minus 1 times x plus 1. What about that other parentheses? Yes, I can. It's almost the same thing, because it is. Then I'll set each one of those factors equal to 0, and I'll come up with the answers x equals 1 and x equals negative 1. Now remember, they're going to occur twice, right? So both of these have a multiplicity of 2. Right? Both of them have a multiplicity of 2. I'm going to go ahead over here on my graph and I'm going to go ahead and plot those 2 points. So there it is, a negative 1 and a positive 1 right there. Multiplicity of 2 simply means that the graph is going to touch that and change direction. Maybe from the top, maybe from the bottom. I don't know which yet. I need more information. What other information might I need? Well, a y-intercept might be helpful. So let's see here. When I plug 0 into my equation, it's g. When I plug 0 into my equation, what do I get? So 3 times 0 to the 4th minus 6 times 0 squared plus 3, I get 3. So that means the y-intercept is at the point 0, 3. I'll go ahead and plot that. Starting to get a better idea of what this graph may look like. The other thing is then the end behavior. Well, let's see here. The degree is even, and the leading coefficient is positive. So what does that tell me? That tells me my 2 ends are going to point up like this. So that means in my graph, I know I'm going to have to go up like this on the 2 ends, right? The 2 ends are going to point up. From here, it's now, let's create a table of values. Let's take a look to see what different values I want to pick. So let's see here. This will be f of x, this will be g of x. I know I'm going to have the point negative 1, 0, and the point 1, 0. I also have 0, 3, which is already a point that's there. So what other coordinate pairs could I need? How about 2 and negative 2? Let's see what happens when I plug those into the equation. In both cases, I will get 27 when I plug it into the equation. So that's off the graph, so I don't have to do anything like that. But what I do have now is a good idea of what this graph looks like. I know that I'm going to go down here, I'm going to touch that graph, I'm going to change direction because it has an even multiplicity. I got to go up to get through that y-intercept. I'll change direction again because I got to go down through the 0 of 1 or touch that and then change direction and go the other way. I get a really good idea of what this graph looks like and something that you can, of course, use Desmos to check yourself. All right, folks, pause the video right now. I'd like you to give this one a try. I'd like you to try x to the 4th minus 2x squared plus 1. I'm certainly not going to work through it in the same amount of detail, but I will reveal the solutions to you momentarily. The first thing I'm going to do is I'm going to set the equation equal to 0, and I'm going to factor this. And that factoring looks a little something like this. And we'll find the solutions are x equals 1 and x equals negative 1, both of which have a multiplicity of 2. From here, we're going to figure out what the y-intercept is, which will be at 0, 1. I'll take a look at my end behavior. And my degree is even and my leading coefficient is positive, so I know both ends are going to point up. I'll now take a look at a table of values, which again, because I have these two zeros at -1 and 1 and 0, 1 there already, I'm just going to simply use the value of 2 and -2 just to kind of round out my table of values, which will give me y values of 9 in both instances. I'll plot these points, so -2, 9, probably up there and off my graph, -1, 0, 0, 1, 1, 0, and then 2, 9 again up here. Knowing what I know about my ends, I know my two ends have to point up, and I'll get something that will look very similar to my last graph, but just a lot smaller of like a little W or a little curve there in the middle. All right, folks, this kind of ties a lot of stuff together from everything that we've been talking about. So really take your time and get this and have this ingrained in your brain, because it's really going to help you to understand what a polynomial equation will look like. If you have any questions, as always, keep track of those and make sure you ask them. And we will practice more of this tomorrow. Good luck, folks. See you soon.